Okay, hello once again, guys. In this video, we're going to study insertion of new elements into an array. So let me just open this up. So there are many ways to insert an element into an array. We can enter it in the beginning of the array, that is in the first index. We can enter it at the end. And like if we already have a sorted array, let's say we have an array 2, 3, 5, 7, 9, and we want to enter the element 6. Obviously, we don't want to ruin the sorting of the array. So basically, we want 6 to go here, right? So we're going to see how we can do that as well. So firstly, let's look at how we can append an element to the end of an array. um, Whenever you want to enter an element into an array, ideally you should create a new space in memory. That is, you should dynamically initialize a memory location. So let's say we have this array 36381. If you want to enter a new array, ideally what you should do is create new space here and then add, let's say 14 is the number you want to add. That's what you should do. But we don't know how to do that, not yet at least. You'll learn when we do pointers. So what we must do is create an array that's large enough to accommodate our needs and keep track of how many elements have values, like actual values. Let me explain with an example. Let's say we have an array that's of size that has, I mean, that in according to C++ is of size 100, and we have a variable size, which tells us how many elements are actually there in this array. Now don't confuse this C++ size with our variable size. C++ size is 100 by default because we've declared it to be 100. This variable size tells us how many elements are present in this array. So the elements that we have, it turns out the size is 5, so the elements we have are 3, 6, 4, 13, and 27. So what we want to do is we want to add a number, let's say 17, to the end of this array. There's actually a lot of space, so basically the index after 27 should become 17. Now in this case, the size is 5. So the 5 actually refer the if with the size is 5, but the last element has index 4 because we start counting from 0. So the new element should have size index 5. The new element should have index 5. Let me repeat. The size is 5. The last element has index 4, and the new element should have index 5. In general, the new element should have index size. So what we do is we say array size is equal to new, where new is our new element. And then we also have one more element in the array now. So we increment the value of size to 6, because size is the variable which keeps track of how many meaningful elements we have. So that's basically entering an element into the end of an array. Now, if we want to enter the new element in the beginning, what we have to do is shift every element to the right and then put our element in index 0. That is, let's say we have the array 2, 6, 5, 8, 9, and we want to enter a new element here. We don't have space in the beginning of the array, at least not if you store it with some brains, because you don't want to store the first element in the middle of an array. That's just stupid. So we don't have space in the beginning. So what we do is create, basically 2 should go here, 6 should go one step to the right, 5 should go one step to the right, 8 should go one step to the right, and 9 should also go one step to the right. Realize we actually have space because it's a size 100 array. We just choose to ignore the other 95. So what happens is basically we have something here, and then 2, and then 6, and then 5, and then 8, and then 9. Everything gets shifted to the right, and here we can enter our new variable, our new number, new. Let's call it new because it's a new number. So the algorithm for that is basically for all elements from I size, I is equal to size, I is smaller than 1, I is equal to size, that should be I is larger than 1, as long as I is equal to, at first I is equal to size, as long as I is larger than 1, what we do is AI is equal to AI minus 1. That is, if I is larger than 1, that means that wait, let me start over. As long as I is larger than 1, we can make AI equal to AI minus 1, and we decrement after each time we execute the loop. So initially I will be equal to size, so a size will be equal to a size minus 1 initially. And since the index size refers to the element that's after the last element, because we start counting from 0, the element that's after the last element will become the last element in our first iteration of the loop. That is, 9, which is here, will go one step right, and then we decrement, and then we get I is equal to size minus 1. So I is equal to size minus 1 is equal to I is equal to size minus 2. I is equal to size minus 1 refers to the index that is present at this position, at the last position. Wait, oh my god, I'm gonna start this video over. Control Shift